Hi everyone. Today we are happy to introduce Olaf Thielke. With over 3 decades in software development, Olaf has worked on projects in New Zealand and worldwide, sharing best practices and guiding developers to grow their skills. And today he will talk about clean architecture, crafting flexible software systems. We are Tech Excellence, and as you already know, our vision is to raise the bar of technical excellence across the world. With our team, Valentina, she is founder and organizer of Tech Excellence. Daniel, Oliver, and myself, we are co-organizers and co-hosts. Don't forget to register for our Tech Excellence conference happening this November. Only a couple of weeks left, and don't miss the opportunity to learn from these amazing speakers absolutely for free. You can register via this QR code or on Meetup app. A huge thanks to our sponsors, Option, Mock IT, and Code Artify. Our sponsors offer a bunch of e-learning courses. You can also learn from them. You can join us on Meetup app and follow us on different social media platforms such as Meetup, YouTube, LinkedIn, X, GitHub, and Discord. But before we start today's session, I would like to remind you, you can leave your comments and questions anytime in the chat down below. At the end of the session, you will have a 30 minutes time slot for discussions. And Olaf, enjoy the presentation.
Thank you, Alina. Thank you, Valentina. All right. Hi, I'm Olaf Thielke, and today we're going to be talking about clean architecture. So, this is a little bit about me. I'm a global software engineering consultant. I live in Auckland with my wife and 4 children, 4 sons. I've written over 300 articles on software engineering that you can find on codecoach.biz. In the blog section, there's lots there, and also on 1%.dev in the newsletter section, some there as well. Those are 2 sites that I maintain with regards to software engineering excellence and software craftsmanship. I'm an expert with 3 decades of experience in software development. I'm very passionate about clean architecture, the solid principles, clean code. One of the services I perform for my clients locally here in New Zealand, Australia, and also internationally is a legacy code transformation. How to change legacy code safely into something that's more maintainable, less rigid, more flexible, and simple to maintain, so you can develop it again without the fear of breaking it. And test-driven development, quite passionate about that as well. And helping teams build better software through craftsmanship is my motto. All right. Let's get into it. Clean architecture, crafting flexible software systems. As I like to call it, all Lego for programmers. This is what clean architecture gives you. It gives you the ability to interchange entire subsystems. And I'm going to show you this today in code, because I know you want to see the code. I'm going to show you how you get clean architecture and how you get the sort of Lego-like feeling where you can easily exchange entire parts of your system just through configuration. We're going to have a look at that. All right, let's have a look at the purpose of software architecture. What are the sort of common challenges that we get in our software, especially the software that's been around for a number of years, has been actively developed. It's now, brownfield or maybe, even legacy. Complexity builds up, right? it's difficult to sort of really still undersee what's kind of going on. Everything depends on everything else. And as soon as we have got complexity that's building up in the system, it means that any kind of changes that we make are likely to be more complex than they need to be as well. So complexity builds on complexity. This is a bad trajectory to be on. Any kind of new developers in systems like that are going to have a hard time getting their head around it. What's kind of going on? You need long documents that explain what's kind of happening. Wouldn't it be better if the software was just really easy to understand? Code was written like English, and the pieces, this is like the Lego part again, just kind of fit together the way they ought to. They naturally make sense. Okay. Fragility. What is that? It means that when we've identified a bug in the system and we change it, when we've got fragility in our system, we're likely to, through fixing that bug, to introduce more bugs. So you kind of get this cascade of bugs and defects. It's just not good. And actually, a fun part of fragility, a fun story, how it's been explained to me, is it basically means that when you turn on the light in the kitchen, your bed is on fire. So it's not something that you want. It's unexpected, and it's like in an unrelated component. It's in your bedroom. Something there goes wrong when you turn on the kitchen light. Not good. This is another symptom of problematic software. There you go. Unpredictable ripple effects across the system. Yeah, not good. Rigidity is another kind of symptom of older software that isn't designed in a sort of clean architected way, where even small changes, we want to get a small feature in or make a small change to a feature. And what we do get is that we need to, when the system is rigid, we need to make lots and lots of changes to, shoehorn the alterations that we want to make to the system behavior. So instead of making one change in configuration, or maybe 2 or 3 changes in our code, we have to make 53 changes. Yeah, not good. Especially if the system is fragile and rigid, then we get sort of like interactions where we have to make lots of changes to get the system behaviors that we want into the system, and those changes are likely to cause cascades of bugs, huge problems, and we see this in systems everywhere. Right, there we go. Big effort even for minor updates. So those are some of the common software challenges that we get, and architecture can help there. So what is software architecture, and how does it help us? Well, here we go. Software architecture defines a system structure and principles aiming to facilitate easy changes and maintenance while supporting business goals. So that means that a good system architecture helps us to make changes to the system, easily, quickly, and cheaply. And those changes also work the way we expect them to. If our system architecture if our system architecture implies that we have to make lots of changes, and those changes can potentially cause problems, then our software architecture isn't good. It's failed us. And software architecture is about our system. It's not about our infrastructure as code, or it's not about Azure or AWS. It's about how we write the system code, and how do we compose that system. Sure, let me just grab a drink. Thank you. Okay, common pitfalls in traditional software development. This is how we traditionally write software, okay, where maybe with the system, we start with a database. Oh, this used to be the case. So when I started software development, however, I still see it. Let's start with a database or with web. Okay, these are the things that we know about. We know that we want SQL Server or Postgres, and we know we're going to use the web for our API or our front end. So therefore, let's write those first. And then, we're adding, we've got some services, some external interfaces to external services. Hey, security kind of needs to be considered as well. And obviously, security is hugely important. Cool. Then we've got caching, we've got logging, tracing, all these other things. And then right at the end, we get business logic. I was like, okay, hold on. This is just a model. Oftentimes, the business logic is not explicitly separated from these other components. It's written alongside, and that's the point I'm trying to make here. Business logic is coupled and heavily impacted by these other parts that kind of come into it, and this is less than ideal. We tend to get some of the problems that are described earlier on because of this sort of back to front process. So how should we be doing it? How should we be writing software? Well, before we get into that, let's look at another problem that we tend to have here. I've given an outline of a traditional three-tier topology. Right? We've got a presentation layer that's volatile, all right? And what do I mean by volatile? It tends to change rather frequently, right? Oh, that button, I don't like the blue, change the shade a bit, move it down 3 pixels and over 1, okay? And the presentation layer depends on the business logic layer, which tends to be more stable because our processes are fairly well mapped out. Okay, as part of our workflow, we do this and this and this. Okay, and then our data layer, which is also, can be somewhat volatile, somewhat unstable, is another word for volatile, where, okay, cool, we've picked the database, but, we used to work with store procedures, now we want to swap to some sort of ORM, or we want to, normalize our database more. So we change the table structure somewhat. So if we design our topology this way, we are in a bit of trouble, right? Because when there is a change to the data layer, okay, and the business logic layer depends on the data layer, so maybe it depends on the particular models in particular, and those models that we have in the data layer are used by the business logic layer and potentially even bubble up to the presentation layer that they use there. If the data layer changes, then those changes, are cascaded throughout the system, potentially all the way up into the presentation layer. What's a better way of managing it? Well, we have that red arrow. What if we reverse the arrow? What if we were to say, hey, the data layer, changes really shouldn't be affecting our high-level business logic, which is more stable. Why don't we reverse that? If we reverse that arrow and models and changes in the data layer didn't affect the business logic layer, then the business logic layer, the stable part, can be more stable than it would otherwise be. All right. So volatile things, if stable things depend on volatile things or unstable things, then they likewise become unstable, which is problematic. Instability here means experiences changes. So if the data layer changes in the previous diagram, it means that most likely we have to make changes in the business logic layer as well. All right. Okay. Let's have a look at clean architecture and how that can help. What is this? What is this clean architecture? Well, There we go. So clean architecture is a software design philosophy that separates the elements of a design into ring levels. We'll look at a diagram shortly. An important goal of clean architecture is to provide developers with a way to organize code in such a way that it encapsulates the business logic, but keeps it separate from the delivery mechanism. Okay, so business logic is center and isolated from delivery mechanisms, which are basically the technologies. So we keep business logic separate from the technologies. Okay, what do I mean by that? Well, if we had the business logic separated out, into so the business logic is what a system does rather than how it does it. So we need to register a customer, and in order to do that, we need to validate the data. Okay, but is it important that we use SQL Server as a database? No, it isn't. That's a implementation detail, a delivery mechanism, or a how that kind of goes outside. So we separate the what we do from how we do it. And there's sort of like a town wall that separates that sort of interfaces. Okay, so that ring level there separates the business logic from everything else, and that's kind of like the crux of clean architecture. Here we go. This is probably a diagram that you recognize, right? Super cool, where we have the ring level there, the town wall, which separates the use cases and the entities. We'll talk about that a little bit more. The business logic, all right, those two inner circles from the outer ones, the interface adapters and frameworks and drivers. And when I talk about kind of clean architecture here, onion architecture and hexagonal architecture and ports and adapters and they have got a very similar central idea that business logic gets separated from from the technology as well. Okay, so there is a fair amount of overlap. Maybe it differs in some of the detail. Okay, and there's these arrows that kind of point in as well. That basically means that this dependency rule, outer circles depend on inner circles, not the other way around. So use cases depend on entities, and we'll talk about that in a bit more shortly. And interface adapters depend on the business logic, the use cases, and the entities. And the inner circles don't know about outer circles. So entities, don't know about use cases, interface adapters, or frameworks and drivers. Right. So how should we engineer software? I showed earlier on how we tend to traditionally write software. This is okay. How should we be doing it? Well, we should be writing the inner part first, entirely isolated from all the outer stuff. So well, how do you do that? And we'll have a little bit of a look at a use case. How we might do that, how we might approach that. So we write the entities and the use cases first. So what we do, and I know you guys want to see the code. We're going to have a look at a fair amount of code, and I'm actually going to show you how it works, how clean architecture in .NET, how you can implement it, and how quickly you can swap in and swap out in entire subsystems, which is just so cool. I just love it. This is my favorite talk. Alrighty, and then you write the how. So the business logic with the what, we write that first in isolation from all the technology, the web, the database, any kind of additional services, the infrastructure for AWS or Azure or Google Cloud. All of that we'll deal with that later on. The most important stuff is what business problems are we trying to solve? What are the processes? And we express that as code. I showed the dependency rule. Outer layers depend on inner ones, not the other way around. And yeah, That's really kind of crucial part of this. And okay, what are the different components? Well, we have these entities, the very core of our concentric circle diagram there. They encapsulate enterprise-wide business rules. Maybe, customer numbers are 9 digits. There you go. And that applies everywhere. That would be, you could encapsulate that as a validation rule in an entity, in a domain entity. That's what they're sometimes called as well. Right? It's at the very center of the clean architecture. Entities, might know about their peers. So maybe a customer registration might know about a customer entity. Okay, so the customer registration is like an entity for registering a customer, while an actual customer, which might contain this customer number with 9 digits or whatever, right? That is a peer of it, and they might know about one another, but they don't know the next level up, which is the use cases, which we kind of come to now. Use cases are application-specific business rules. So, for example, if you do have a system and it does 200 different value-producing, workflows, then you might have 200 use cases in your system if you've, gone to express your system, in a cleanly architected way. And sometimes, that might, it doesn't mean that every use case is a particularly complicated workflow. It could just be, hey, get me all the orders for a customer. So it could just be a lookup that's ultimately to the database just to retrieve some data. Not every use case will have, a really deep and value-adding workflow behind it. Okay, there we go. Manage business workflows. So this is a step-by-step process, right? Sometimes there is just a single step. And the use cases with that arrow pointing inwards, use cases know about entities, not the other way around. And this is architecturally, I call it a town wall. The business logic boundary this is really important. So that separates the business logic from everything else out. So from the delivery mechanisms or technologies. Inside that town wall is the business logic, and that's protected from web, database, all this other stuff. And the other stuff kind of depends on the business logic. So these interfaces are there to keep at bay the delivery mechanisms, these technologies. Okay, we're going to see this in code a little bit later on, but don't kind of depend on it. So business logic, is encapsulated by interfaces. All right, so I think in hexagonal architecture that's called ports, and the ports and adapters as well. So yes, they serve as plug-in points for the technologies, because obviously, at the end of the day, the business logic, will need at runtime will need to use a database to, or write to a file or somehow persist the data. Okay, but it doesn't know at compile time what exactly we're using for databases. A Postgres is a SQL Server. No, we don't know that. There will be an interface to isolate the mechanism from the business logic. And yes, inside that town wall, we don't mention any of the technologies. Even in a comment, you wouldn't kind of like say, hey, here we're saving to the SQL Server database. It's like, well, why would you do that? You semantically, you have locked in the developer to think about a SQL Server database is where the data is being saved to. It's best to kind of not mention technologies at all. That gives you the maximum, not even a comment, gives you the maximum flexibility. The business logic is just how we're doing it, not what we're doing. So what we're doing it, not how we're doing it. I kind of got confused there myself. Yes, so business logic layer focuses solely on policy. So there's this definition of policy versus mechanism. Policy just means what we're doing, not how we're doing it. Interface adapter this is the level outside the town wall that provides the connectivity between, hey, this is the raw technology and frameworks, to the business logic. So this is the code that kind of connects to these interfaces to the town wall. And it's okay for the interface adapters to know a bit about what's happening inside, just not the other way around. So that's why there's a little arrow that kind of points from the interface adapters into the business logic. So yes, specific connectors to frameworks and technology, your SDK. So for example, ORMs live there because they connect the business logic to bridge the gap between the business logic. We want to save some customers or customer orders to, okay, we're doing this to a Postgres database or SQL Server database, or just writing it to a file. Yep, can know about some of the entities and the use cases. That's cool, and it connects to the technology. Frameworks and devices. This is like the last shell, if you will, the outermost shell that presents the actual technologies, your libraries and frameworks. But for something like Postgres or SQL Server, might be okay. Not just the database itself, but like some of the generic data access technologies, like the SQL Server might be ADO.NET, or now with Postgres, it would be some Postgres library. Cool. All right, hopefully that makes sense. Benefits of clean architecture. Framework independence, architecture isn't constrained by external libraries, which of course is fantastic. You don't know about these libraries, you keep them at arm's length, right? Your libraries and SDKs. And you can test, if you write your business logic first in an isolated way, then you can test the business logic. And you can even write it, which is something that I love to do. I love to write my business logic using test-driven development, where you write a little test and then you extend the functionality little by little until you've got it, the fully fledged business logic. Right, there we go. User interfaces can be changed without affecting any of the business logic. Business rules aren't tied to SQL Server, Postgres, so you're not dependent on web. You're not dependent on the database. All that is abstracted away. Yeah, there you go. I mean, this is actually the way to sum it up. Your core business logic, the thing in the center there, doesn't know about the external world. And so modularity and kind of pluggability are very much a part of this. The system is divvied up into these sort of small, independent, interchangeable components. Yeah, there you go. And if you've got that modularity and that pluggability, then you can easily, and I will show that to you shortly, easily swap in and out and components. All right, let's have a look at a case study. All right, let's say we've got a case study like this. New requirement, we should be able to register customer in our system, and someone has written up this part, which is the sort of step-by-step flow. Obviously a very technical person, because they've kind of said, hey, it needs to be HTTP post, all right, to our API, and OAuth 2 secured endpoint, and by the way, this is the virtual URL, right, that we've kind of got as well. And all these kind of parts, right? And even to the point where we send a customer welcome email message, successful, when we've had a successful registration. And when you kind of look at this, you kind of wonder, okay, what's kind of going on here? What part of this is actual business logic? Because it's kind of important to understand that particular aspect of the analysis. If we don't know what's business logic, then we don't know how to code it up. And yeah, so let's have a look. Next slide. We've done a pick apart. Register customer for the use case, which is the what we do, and I've outlined the parts that are business logic. So we're registering a new customer, that we're doing it, via mobile and web client. It's neither here nor there. RESTful web API doesn't kind of matter. Sure, it's great to host it in the web API, but what if we want to later on put it into a Windows service or into a Lambda or something like that? Well, we should be able to transfer our business logic without having to account for any of these changes. Step one isn't business logic. You can see it's fully about technology. Step two, we're validating the customer information that we've got first name, last name, email address, and maybe now I've actually just recently updated the code example, maybe mobile number as well. Okay, that has to be there. If the customer already exists by email address, yeah, that's an important part in the SQL Server database. No, that's technology, obviously. Then it's an error, and we're returning a 4 and 9. Okay, that's technology. Otherwise, we save the customer with a unique identifier, a customer number, or maybe a GUID or something like that, to the database. Well, we save it somewhere. It might not be a database as far as business logic is concerned, but we do save it somewhere. And we return in step 5 there, the customer, including the unique identifier, the mobile web client, HTTP status, neither here nor there. And with the nice to have, send the customer a welcome message after the successful registration. Why have I left out email? Because we might find other mediums of sending welcome message. Maybe we want to send an SMS message, a WhatsApp message, or some other way of an in-app notification. Sure, the way we want to implement this first and foremost might be with email, but we just want to send a welcome message. All right, and so how do we kind of start out? Right, let's explore this. So this is a quarter of the standard diagram, right? And the sort of better entities, use cases, and there is the town wall, the business logic boundary. We would develop this part first. Well, let's create a class called register customer use case because we're registering a customer. I like to call it use case. I think Uncle Bob likes to use interactor. I think even he might be switching over to use case. And one of his videos, he kind of said, hey, this is about use case. Maybe I should have called it use case. And then, right, what entities do it depend on? Well, a customer registration kind of comes in and a customer comes out of the process. Well, these would be entities within the scheme of this particular process, right? So these are dependencies. Customer registration would have first name, last name, email address, mobile number. Potentially, there might just be a plain old, C# object. Customer, maybe that, or customer registration probably contain a bit of validation as well. They could be subordinated, delegated to in here. It doesn't all need to be in the use case. Okay, what else is there? Well, we want to be able to save to somewhere, all right? So there might be an iCustomer repository interface. And because we're sending a welcome message, well, how about an iCustomer notifier? for sending a welcome message to the customer. And okay, what does that look like? I've got some code. All right, there we go. I hope that's large enough. So business logic is, so this is a C# .NET solution, and I've put business logic into its own project. I've got a use cases folder. I've got a couple of use cases, register customer use cases there, and get all customers as well. Register customer use case is what we're interested in. And you can see that we've got the iCustomer repository dependency and the iCustomer notifier. They're part of the town wall, all right? They basically expose the outer world to us, but we don't know the details. So this is what we use to connect to the database, or some other way of persisting, and also for sending the welcome message to the customer. And there's only one public method with these use cases. So this might be overloaded, a different way of doing it. But here we go, register customer. Customer registration is what kind of comes in, right? That's the parameter, and the customer is being returned. And nothing in here talks about technologies at all. It's just about the business, the workflow that we need to undergo in order to register the customer. Okay, as per the yellow highlighted bits in the use case pick apart, what do we need to do? Well, we need to validate the registration. And that's a private method, okay, where we, down here, what do we do? Well, we want to make sure that, we've got a customer registration, else is a problem. Then our registration can validate itself. We don't have to do that in here. So you can delegate to objects. We can say, hey, validate yourself. Okay, what does that actually mean? It means, and this is how I've implemented it, well, make sure we've got a first name, a last name, an email address, a mobile number. This is, rough and ready validation. I've just checked that whether we've got a null or white space, not that the mobile number is of the correct format, or an email address. That would be, this is a prototype clean architecture solution, and I'll show you where you find that on GitHub in a later slide. If you want to clone it, it is good to have a look at. Okay, so we validate, and the registration can validate itself. And then what's the next level that we need to do? It talked about that. We want to ensure the customer doesn't already exist in our repository. So I'm using an abstraction here, repository, because we don't want to go ahead and necessarily use a database here. Remember, this is just what we're doing, not how we're doing it. So whatever the repository is at runtime, SQL Server database, Postgres, JSON file, we get the customer by email address. If we have an existing customer, then throw a duplicate customer email address exception. All right, cool. Else we're done. And this is the workflow up here that we've got in the public register customer method. Okay, cool. We've dealt with validate. Now we're converting the registration to a customer. I think let's kind of quickly go in here. All right. It's just a one-for-one convert, but we're giving it a customer number here. I've just kind of given it a GUID. That works. And then once we've done that step, we've given it a unique identifier. We can save the customer to our repository, cool, which we do here, whatever the repository ultimately is. And we then send using the notifier. It doesn't say emailer because it might not be email, it might be SMS text. And we'll run it in a minute. I can show you that, hey, can send an email or can send SMS text or a WhatsApp message just by switching some stuff in the some IOC configurations around. Well, we're sending a welcome message, and that might be an email, might be something else. All right, cool. Before we do that, though, let's kind of quickly. So we write that part first. No technologies. Oh, and by the way, how do we know there's no technologies? Because for the business logic project, the dependencies, there is no dependencies on any of these other projects. Okay, this is entirely by standalone. Some of the other projects will depend on business logic, but business logic doesn't depend on any of the technology projects. Cool. So this is what we write first when we go ahead and express clean architecture as a process. And well, how do we progress from here? You can sort of see, okay, there is what we have. How do we now make it work with actual technology, right? Because having an iCustomer repository, an iCustomer notifier isn't so helpful by and of itself. Cool. Well, we might implement a customer emailer that sits inside the interface adapters kind of ring and implements iCustomer notifier, right? And that guy will have some additional dependencies. What kind of goes into a customer emailer? What are the sort of dependencies? Well, we obviously need something to send general emails. Maybe we want to have the from email address, our sending email address. That might change from time to time, so we probably want to get that from configuration. If we are sending templated emails, then we probably want to retrieve an email template with placeholders and then replace those placeholders with the information from the customer. What does that look like? That looks a bit like this. So here you go. Email configuration is more of a concrete guy. You can see concrete classes or modules have got a hard outline, and abstractions have got a sort of dotted outline. So iEmailer is dotted. And why didn't I use an AWS emailer here? Why did I say iEmailer? It's because we want to give ourselves options, right? We want to give ourselves an option of sending email by SMTP or maybe AWS or Azure ZenGrid, or maybe some other way of doing it. Maybe we just want to put the email on a queue to be processed later on. There's an iEmail template repository. This is, well, where do we get the email templates from? Maybe from a JSON file, maybe from some sort of other configuration, but we want to give ourselves an option there as well. iPlaceholder replacer, okay, some sort of thing for replacing, there's an interface for replacing the placeholders in the email template, right? Maybe that guy could be concrete, right? But potentially placeholder replacer would be dynamic on the brackets or the delimiters that we use for email. So for the placeholders that we replace, there you go. So we write the placeholder replacer. Good, we've got a concrete bit there now. What's next? Well, maybe we've got an old SMTP server sitting around. So why don't we write an SMTP emailer? And that connects to the technology, which is SMTP. Well, what about, well, all right, cool. So we've done that, but now we want to switch to AWS. So SMTP really is doing it yourself. Probably you wouldn't want to do that these days. Okay, let's write an AWS emailer. Cool. We can switch these in one for the other. At every stage we have got, so the further we delegate into the mechanisms, the more we have, we always give ourselves an opportunity to replace one, way of doing it with another. There we go. For the iEmailer, we don't hard code in the customer email that when you want to use AWS. We give ourselves the option there to use the AWS emailer. And the way what you can sort of see is that you kind of go from a high level mechanism and you kind of split that up into the sort of smaller responsibilities. Single responsibility principle kind of comes into it. And of course, open close principle architecturally as well, whereby we want to write a new part and a new class, like the AWS emailer, and plug that in. We don't want to write the AWS emailer in the same class. Right, and like I said, for example, maybe we've got RabbitMQ and we just want to queue the email for the time being, and then it can be sent to some other microservice or whatever to be picked up by microservice or some other part of the system. Cool, we can do that as well. However, the details that we're using a RabbitMQ email enqueuer or SMTP email or AWS email doesn't need to be known by the customer emailer. And right, leave a little customer repository and email template repository. I can show you that in code, what I've done there, but not on a diagram. By the way, down the bottom here, it shows where you can find the particular code for this. There you go. Olaf Thielke. Oops. Right, what about the customer SMS sender? Let's have a look at a different way of doing it. We want to switch from email to sending customer texts. Well, the core shouldn't change, right? So once again, the sort of architectural version of the open close principle, all that inner stuff that's in the business logic, given it doesn't know about the outside world, means that it doesn't need to change. Customer SMS sender depends on services. Some of those are similar to what we might have had with the customer emailer, like the placeholder replacer. Sure, we're now getting SMS templates, which are probably much shorter, much more concise, condensed, because text, SMS text language tends to be different. Potentially it's the same, database that we're using, but here we're hiding it behind an SMS template repository, got the SMS sender. But once again, here we probably get to reuse the placeholder replacer. And in the code, you'll see I've used Twilio to send SMS texts. However, in New Zealand, it doesn't work. We have to use a shortcode. And I didn't want to pay $800 for the sake of an experiment, because that's how much it costs. But I did implement the Twilio WhatsApp sender. WhatsApp is also useful for and could be considered a SMS platform, a small, so short message service, which is what SMS stands for. Uses the same Twilio SDK, but obviously works a little bit differently. And hey, if Twilio doesn't work for you, maybe you could use the Vodafone SMS API. There you go. But the customer SMS sender doesn't need to know these implementation details. Great. Oops. All right, let's hold on before we kind of go there. Let's have a look at the code. And so here is my startup file. Configure the services. So I've configured the use cases as part of this method. Here's call here. Let's have a look what we've got. All right, it's just the get all customer use case and the register customer use case. Cool. Configure the customer repository. Well, I've provided you, if you clone this particular project, by the way, the README file is a bit out of date. It's all done through Docker Compose, so it should pretty much work out of the box as long as you've got Docker Desktop installed. But we can configure, an in-memory database, JSON data file, Postgres database, and we can even use some caching and the database. So there's like a component in there to switch from one to the other. I'll kind of go with the JSON data files. Go. Yeah, that's a bit more fun. Okay, what happens in here? Oops. The customer repository is the customer JSON file. Email templates also comes from a JSON file. I haven't separated those out, so all storage is to JSON files. And if we have a look I've got a data file system project. So there you go. There's like, okay, it's been seeded with Wilma Flintstone email templates. As you can see, there already an SMS template is there as well. Let's try those out. Oops. Okay, let me just kind of quickly check out. So that's the JSON for the repository. We're using JSON files, and for the customer notifier, maybe to start with, use the customer emailer. Cool. And then it kind of gets divvied up further. So here we go. Customer notifier is implemented by customer emailer. There's a placeholder replacer, email configuration, which is sort of divvied up into, hey, dynamic emailing, and this is what I like to do and this is what you get through Clean Active, which is just beautiful. It's like, if I can't be bothered to develop anything further, like I didn't want to do dynamic configuration, I could just quickly hard code the email configuration in a separate class that implements email configuration, actually that was a concrete class that just fills the email configuration in a hard-coded way, and then do the dynamic email configuration later on. Configure emailer. Let's kind of go in here to see whether, and then we've got choices: null emailer, AWS emailer, or SMTP emailer. If I don't want to send emails, I could connect a null email, so it pretends it sends email. Here we go. Let's go with the AWS emailer, which is configured down here. And yeah, all right, let's see whether this works. Start it up. So I should be getting an email once I register, once this comes up, to start with. Okay. Oops, hold on. Okay, here we go. Localhost 8081 customers. Okay, there we go. Wilma Flintstone, as you kind of saw in the JSON file. There we go. We got that, and it had been seeded with. I've got Postman, which I'm going to drag over onto the other screen. Okay, and I'll make this my details. Okay, there we go. Has just been sent. So that will just register the customer. So you go, customers register. Excellent. So I guess that means that if I go to my email, I should see. Okay, hold on. There we go. And welcome to, I've called it Super Widget Mat. Okay, in the JSON file, I didn't pay a huge amount of attention with regards to new lines. There we go. That's what we've got. Let's switch over to something else, and we can do this through configuration. Let's switch over to customer repository. We'll make that a Postgres database. So I'm going to comment this out. All right, and okay, go. And I've got the Postgres database, which is run through Docker Compose. I'll set up the container for it, and so I'll run the container as well as what else do we want? So that's customer notifier. Maybe we say let's go SMS. And for SMS, let's pick wanted to actually, okay, there's the SMS sender. I actually wanted to have the WhatsApp sender. Oh, okay, hold on. customer sender. Okay, configuration. Oh yes, let's have a look at the configuration. SMS configuration, dynamic WhatsApp configuration. Cool. So we'll kind of get it out of configuration file and the SMS sender. We don't want to send SMS. We actually want to send a WhatsApp message because SMS didn't work for me. However, wherever you are in the world, if you're not using shortcodes or your country doesn't do something else weird, this should actually work for you, especially if you're in the US. Just to sort of prove the point, I'm going to show you my Twilio. There we go. That's my, hopefully you can see it. That's my SMS. Okay, and I'm going to stop that, and we need to recompile. So hopefully we now have connected up to the iCustomer repository, we've connected up Postgres, okay, just the configuration, and Twilio WhatsApp sender. Okay, it's running, and if firstly, so let's. Okay, cool. Fred Flintstone was the one that's seeded, was a seeded customer already in the Postgres database, so we're on the right track. Excellent. And now I'll bring up, Postman again, and we'll send that in. Fantastic, 200, okay, register that customer, and hopefully, I'm looking at my Twilio, and I don't see anything yet. Probably takes a sec. My WhatsApp. Okay, not there yet. Last time didn't take so long. Maybe I've screwed something up. Sometimes that happens. But we've got a 200. Yeah, should be all good. Okay, well, we'll have it sitting here. Let me just kind of walk through the rest of the slides because we're having a lot of time left before we're going to get into the questions. So implementing clean architecture in projects, in your own projects. Practical tips, the stuff you have to know. So really, I recommend that you kind of don't start with a sort of the delivery mechanisms. You start with, and I know this feels a little bit weird. It definitely felt weird for me when I sort of first started getting into this 10, 15 years ago. You want to kind of write the business logic first, which means there's no reference to any kind of database or web technology or anything like that. So yeah, start business logic first and work out. Define, yes, your workflow, but this is basically another way of kind of saying, hey, keep the technology at bay. How do you know about the web and database and all that? It's through those interfaces in the town wall and in the business logic boundary. That's how you at runtime get to work with it's SQL Server or Postgres, or it's actually just JSON. Yeah, and through your unit tests, make sure that your business logic works how you expect it to, and of course it should be eminently unit testable because it's very clear. Should be very clear in your business logic what's kind of going on, and because you shouldn't need to mock or stub or spy a lot of these external dependencies. So and you'll see the unit test for it. Just need to do that with the iCustomer repository and iCustomer notify. Was it called with the right arguments? And it's also useful to kind of validate it against a paper-based process. Like, how did I know that that I'd coded up the registration correctly for the customer It's because I could say, well, if this was a paper-based process, would it work the same? And say, yes. If 50 or 100 years ago, you kind of come into a shop, and there's a storekeeper or a clerk, and you can say, hey, I want to open an account with you. Okay, cool. Here you go, fill in the form, first name, last name, email address. Okay, maybe 50 or 100 years ago, there weren't so many email addresses, mobile number. Okay, great. I filled it all in, hand it back to them. They validate, they check whether it's all there. Then they check against their database, their repository, which is, say, a filing cabinet, to check whether or not I'm already there. If I have forgotten that I've already registered with them as a customer, they say, hey, you're already here in our database. You can go away, or order something. And if not, they write a customer number in the corner of the paper and then put it into the filing cabinet. They save it to the database, and one's done. So it's useful to, think of it that way. Right, and last but not least, there is actually a little bit of a surprise. Did anyone kind of notice the error in that clean architecture diagram that we've got? It's come on. The error is that, and it's funny how that's still perpetuated after all this time. Funnily enough, the outer arrow should actually point, between the interface adapters and the frameworks and drivers should point out. Okay, interface adapters depend on frameworks and depend on the business logic. That's what adapters and gateways do. They work between two interfaces, right? And the reason, this is how the light kind of went on in my head, is that, hold on, my ORM, is depends on the database, not the other way around. SQL Server doesn't depend on Dapper. Dapper depends on SQL Server. So the arrow is the other way around. Yeah. All right. I think that's it. We're on to the question part of the talk. I hope you like that.
Yes, we enjoyed it a lot. Thank you, Olaf, so much for being with us, especially at 5 a.m. New Zealand time. You're our first speaker from New Zealand. Huge thanks for that.
That's cool. I love the stuff so much. I mean, this is such a cool way of designing software. I mean, it's really great. Just love it. So, yeah.
Amazing session. Thanks for it. We do have a lot of questions and a lot of discussions in the chat. So most probably Valentina and myself today won't comment too much because we are very, very interested about your opinion on these topics. So let's start with the practical part. May I know, will the slide be shared? Will you share your slides with the audience? And same question about the code.
The code is already shared. The slides at the moment aren't shared, but I could probably share them. Yeah. It's a good question. I haven't been asked before. Obviously, I should have thought about this before. Yes, I will make it so that the slides can be shared. Yes, the slides will be shared. The code's already shared. You're welcome.
Thanks for that. Then we have a recommendation from Wolfgang. He recommends the book Actionable Architecture Explained by Alistair Coburn. Would you also recommend this book?
I have to admit, I haven't read that one. My go-to, and unfortunately I haven't got it next to me here, is Clean Architecture by Robert C. Martin, otherwise known as Uncle Bob. That's one of my favorite programming books. I should read more about hexagonal architecture. I probably would recommend the book. I mean, Alistair Coburn is, read some of his articles and other stuff. So, yeah.
Yeah, maybe, I could jump in since I've been following Alistair a lot, and even so it's a newer book. So I guess not everyone had a chance to read it yet. I had a chance for short read. I do personally recommend it because hexagonal architecture sort of sets the foundations and then clean architecture builds on top. So I would say both of those books are useful for reading.
Thank you, guys, and thank you, Wolfgang, for your recommendation and great replies in the chat. Okay, let's jump to other questions. Let's start here. It's a bit a longer one. I will display a couple of comments. I faced two options, either call the external API directly from the controller, which would be simpler and quicker, or add to hexagonal architecture. Following the hexagonal structure would require adding multiple classes and mappings, even though there wasn't much business logic involved. Given that hexagonal architecture can feel cumbersome for features with limited business logic, what approach would be best in the case? We also summarized this question for you. When should hexagonal architecture be applied? If the choice depends on the business logic complexity.
Yeah, and here, just before we get the answer, I would like to jump in. So the example is, imagine if someone has a very simple, maybe a CRUD application, it's a to-do app, and all it does is we add to-dos, edit and remove them from the database. Would it be fine to just do the direct calls to the database from the REST API controller, i.e. not use hexagonal clean architecture, or should we use hexagonal clean architecture in all cases, even for the simplest apps where there's hardly any business logic, or just in the cases where there's complex business logic?
It's a great question. It's one of the classics, and at the end of the day, it's up to you. If you feel that you want to, have references to concrete data access logic in your controllers because that's, it's a trivial application, by all means, you can kind of do that. I think where that particular model tends to break down is where a prototype like that is taken and kind of like, oh wow, hold on, that worked. Let's kind of let's turn that into a larger system. So some of that technical debt that you have accumulated that worked fine as a little prototype or a little to-do application that you now want to wrap into the core for a startup or similar. That's when you might kind of regret that decision in not right away, because initially you'll actually it'll appear faster, but in probably not even you. It's once you've left, it's other developers who will have to pick up the pieces and kind of go, hold on, actually, these things have become very messy. On my personal preference these days is to start out as I intend to carry on. So even with something very trivial, not very trivial, but if I intend to kind of extend the system, I will start out with clean architecture right away. And even write use cases for, like I've done there, when the get all customers use case was one of the two use cases. The register one had a fair bit of workflow to it, while the get all customers was basically just a delegated call to the iCustomer, the repository implementation, at the end of the day. I would write that for everything, and you can kind of say, hey, you needn't have written that use case. Why not just kind of use the the iCustomer repository, directly inside the controller. It's by establishing some structure where, hey, for every significant, or for everything that can be done, or that the business wants to be done, every workflow that adds value, and potentially just getting all customers and displaying them on a screen adds value to some admin for the business. I would write a use case, and it just then the system becomes very clean and clear, even if it's trivial, because you never know how long it stays trivial. Maybe, oh, we want to get all customers, but there was some other notification that we want to do as part of that. And if you kind of separate it out into its own use case class, now this is where you would add that additional business logic. While if you sort of did it in the controller, now it would be, okay, you might even put the logic directly into the controller and the system starts getting messy. One downside that I would say about writing systems like this, people have said to me, it's almost too simple and too boring. And yes, a little bit of additional sort of scaffolding needs to be set up for like getting all customers, which is just a delegated call to the customer repository. But I think at the end of the day, if your intent is to be a non-trivial system, it's going to be worth your while. Does that answer the question?
Yes, absolutely. So you basically introduce application layer in every case, even if there is no application logic at the moment.
Yes.
Thanks for that. Let's move on. Should I design all my ports interfaces upfront in business layer, or can I postpone this decision? What is your opinion on this one?
I tend to develop the interfaces as just in time. Okay. So I kind of write, especially when I do TDD on the business logic, like with the register customer use case, I would write the code to validate, and there I don't need any I don't need any interfaces yet. And then when I kind of like come to the sort of first test, is like, hey, by the way, well, for the validation, we are going to get the customer by email address from the repository. Now, this is where the repository kind of shows up, first time. And it's like, maybe I would just ensure as part of my mock, right, my mocking that, hey, I just have a get potentially even without the email address argument. It's like, oh, okay, I just kind of call this, and then I'll change the test a little bit. Now I'm actually making sure that I'm passing the email address in as well. And so I tend to develop my interfaces, out of the business logic, the town wall with the TDD. Okay, so they kind of get developed, and that means that they are exactly how I want them, how they're most useful to me as the business logic.
Mm-hmm. Thank you, Olaf. Are you mostly working?
That doesn't necessarily mean that I might kind of like take a note of what kind of interfaces. I think it's always useful to sort of think a little bit ahead, but then the final sort of version or the version that I need right here and now, that I develop, just in time.
Yeah, and just to add to this one, so Uncle Bob also showed it in Clean Coders, the architecture diagram, there's no restriction when someone chooses to draw it. So someone could draw on paper the interfaces that they think might be needed, but simply not implement them. So I also agree, as you mentioned, implementation, actually defining interfaces in code, it's best just in time.
Yeah, absolutely. But I love this idea, and I think Uncle Bob has said this as well. It's like, look, think ahead, it's draw how you think, what you think the classes are going to be in the system. This is not a wasted effort. Just don't rely on that. Maybe it works out differently through your TDD and oftentimes simpler, right?
We talked quite a lot about developing direction of clean architecture. Let's talk about refactoring in the direction of clean architecture. And we have two questions. Can clean architecture be applied to an existing code base, and what are some practical steps for incremental refactoring? And maybe I show you the second one and you can reply together to this. How can we balance the risk and reward of full version incremental refactor to clean architecture in a legacy code base?
Yeah. In an existing code base that's legacy, it's tricky, right? It kind of depends on a couple of factors. Are you writing new business, new workflows? Then I don't see too many reasons for sort of like having this would need to be known to the team, right? That you're over here for this new work, you're developing the code in a clean architecture way, okay, with a business logic project and the use cases kind of go in there, and your domain entities, cool, and with interfaces out into the delivery mechanism world, yeah, it gets trickier when you've got legacy code, which especially, if it's untested, there, I highly recommend working effectively with legacy code book, where before you make any changes, you characterize ideally through unit tests, the existing code, and then you can, so that you basically got these tripwires, right, that basically ensure that when you make changes to the code, you're not making changes to parts that you don't want to make changes to, effectively, introducing defects, because the stuff is rigid and fragile, right, usually. But then you can slowly refactor, right? So you put some unit tests in place, which might be tricky, and you need to break dependencies. But as soon as you've introduced your changes, and then because now you've got some unit tests, you can refactor a little bit, bring the code into a slightly better shape, which means that you can now introduce a few more unit tests because you've refactored a bit, and which means that you can write more unit tests. So you're on, if you take it seriously, and you're on a path where you're in the hole, but you're digging your way out. You're filling it in and you're working your way out. And then maybe at the end, you can go ahead and you can undertake serious make serious architectural changes, but not at the start, not when you're working with the legacy code itself. It's usually too disruptive to introduce that. You really, in order to safely do it, you need to do it little by little. I hope that answered the question.
Do you have experience in introducing it in big legacy projects?
Not well, because normally I don't work with my clients for months and years. But yes, we have refactored, parts of the system through tests, and refactoring, more tests, refactoring into just sort of like a few vertical slices into a cleanly architected system, and that was very cool. Yeah, it was like 46. Well, in one instance in particular, 46 lines of, oh my God, I don't know what's going on. Get some data from over here to over here, and it looked like all these services and interfaces that were very service specific, and it's like the trick was, as it usually is with the team, to sort of say what is really kind of going on here. And it took a while to realize that actually in this instance we were just getting user data from a data source, and if there was something, it gets shunted over to written to a user destination, and it was just 3 lines, and everything else became a plugin. And it was it got to the point where the lead developer even said, Olaf, I don't like it, it's too simple. That was the best compliment ever. Yes, so it can be done. It does take effort, and the trick is to show teams what the difference between business logic and the other stuff.
It's a good sign if it becomes too simple.
I know, it's crazy. It's like, that is great. Now we need to use some sort of enterprise architecture pattern. No, we don't. This is, look how simple this is. Yes, it's too simple.
This is great.
Uh,
So let's move on. And we have another question. Why do we promote hexagonal architecture? Because I keep hearing we change the infrastructure, but honestly, it's rare to change the database. For example, I read someone telling it's about tests. Can you clarify?
Having it's a good question. Having an interface to, protect the business logic from the database is obviously useful from a testability perspective. I mean, the database is a concrete collaborator, excuse me, and protecting the business logic. Also having that so that we can write unit tests not against the database, because that would obviously be IO, and it would be like an integration test. So it's useful for that reason. And I know I hear this argument so often that, look, we'll never change our database. However, maybe you don't change the database for the entire system, but wouldn't it be nice, and I mean, I have found that at least, wouldn't it be nice to use a different kind of data persistence for this part of the system? Maybe our email templates don't need to come out of the SQL Server database. Maybe they could just kind of come out of configuration or out of a data file or something like that. We found that, I don't know, that would be a better way of doing it. It's like, okay, cool. So partially replacing your data persistence is still a useful scenario. So being able to do this doesn't mean you have to, but being able to switch out one implementation for another with relative ease, just by writing an adapter and not making changes in the other parts of the code, is still a huge thumbs up. And of course, it means that the individual parts are easier to understand as well. I mean, all those classes that you saw as part of my demonstration there, they are very small. They got great small single responsibility names. They conform to the open close principle. Usually you just write another, similar implementation so that you can be polymorphic about it. It's a great way to go.
I liked your explanation a lot in the beginning of presentation when you were talking about what and how, separation of what and how. I believe this is also, this is also a good take on why do we need clean architecture. It's also about this separation.
Yes, that's what it's about. And really understanding your system is like, well, what are we doing versus how are we doing it? And I mean, at least in .NET, you are given a little bit of a hand up, because you should be able to put all your business logic into a separate project, and it doesn't reference any of the technologies. If it references, SQL client or Postgres or even web, there should not even be anything to do with web. Well, something has obviously gone wrong. And I think you can use architectural tests. I haven't used them much lately to enforce that as well.
Yeah, and I also want to add one more thing, because for me, that testability was a big argument personally, to be able to write unit tests, and alongside it, it causes separation of concerns, and hence it's less cognitively complex for us to process. It's much easier to read a class where you're just focusing on business logic rather than at the same time thinking about the business logic, your email template formatting, and like SQL statements. So by separating it out, it's like we reduce coupling and increase cohesion. So it's actually also easier for us on our brain as well.
Absolutely. And in fact, that's the sort of way I think of it these days, that I've got certain problems, like I customer notify, we send a welcome message. Okay, how do we do that? Customer emailer. Okay, what are the sort of responsibility that go into that guy, and then so I push the complexity further and further out to the margins until now all of a sudden you are connected to the technology. And that's actually, I love your point around the cognitive load that we have as developers, especially in legacy code. It's this is what I find that's sort of the most important part about software development, and this is where clean architecture help, is unnecessary complexity ought to be reduced. It's unless any kind of degree of unnecessary complexity will add more complexity as we make changes to that code. And if it was just necessarily complex, it would be as easy to understand as possible. It would probably read almost like English. All the different responsibilities are in their own little classes that have got great names, and systems like that are a beauty to work with.
Also,
absolute
the
delight. It's like Lego.
this code. Okay, we have so many more questions. Let's pick a few more.
Okay, cool.
In a project that also follows hexagonal architecture, I have seen all business logic in the services and almost nothing in the entities. Entities were like details. What do you think?
I mean, that's not good. I see that all the time as well, where and I think this, to a degree, this comes from unnecessary complexity as well, that as developers, we overlook opportunities for delegating behavior out to other classes. Like I did there, with here's a case in point, right? The validation of the customer registration data was actually done by the customer registration itself. It's like, why should that be in the use case? And the way sort of because initially, when I did the TDD, I put it in the use case. It's like, hey, I was just testing for behavior. I wasn't testing for structure as part of my TDD, and it was working. But then, of course, it's the refactor step. And this is the beauty of the refactor step, which, when you're experiencing TDD, you realize that to be like the most important step after a while. Because it gives you the opportunity to refactor and simplify. And I realized, hold on, why is this use case doing all this work? That is actually something that could be delegated to some other place. I think, I know this from when I was, a more junior developer, that oftentimes that feels a little bit weird. You want to see all the code in one place. So I need to see everything in this 300-line method, and then I'm happy. This idea that we trust some other code that we have still written that sits in another place still feels a little bit weird. Yeah.
So you do push your business logic down to domain classes?
Yes, as much as possible where it's appropriate, and I think this is where feature envy is a good way of identifying that. I saw, for example, that the customer registration, which had first name, last name, email address, that all needed to be validated. That, hey, was it there? It's like, why is this? But first I put it into a private method inside the use case, validate, and then it was like, why do I have this customer registration dot first name, is null or empty or whatever it is? It's like, no, why am I doing this work that could actually, and I would call it feature envy, right? The wrong class does the work. This is all about this customer registration, class, this customer registration structure. That's where the work should be happening. And of course, it became simpler because in there it just became first name, last name, email address. It wasn't like registration.email address. Sometimes you sort of see the signs. It's hard to see it in legacy code, but in really clean code, you see when something is just a little bit off and you can move it to somewhere else.
I personally see use case more like as a dense of entities. So I call my logic which is in the object in the classes.
Yeah, that's a good point, and I think that this was a good question and discussion here. I want to add on. This is one of the differences between hexagonal versus clean architecture. So in clean architecture, as you explained, the idea is to have rich domain entities, which means essentially the business logic, whatever we can, the enterprise-wide rules. Yes, we would put them in the domain entity. So that's the case with clean architecture. It requires to follow the rich entity approach. Whereas hexagonal architecture is actually lenient on this topic. Hexagonal architecture, all that it cares about is, that we have separation of business logic away from I/O, but it does not tell us, for example, whether or not we should have a rich versus anemic domain. Whereas clean architecture is the one that here is, posing the additional constraint. Hey, let's have rich entities. So this was definitely a good question and good discussion.
We run out of time, but I would love to ask you a very last question because we had a lot of discussions around two topics, and these are validation and error handling. How do you normally approach these topics? Where do you validate? Do you validate in the REST controller and in the use case and in the domain objects, or do you validate at one place? And also, where do you do error handling and how do you use exceptions? These were the discussions.
Excellent questions. So with regards to validation, I don't draw a strong line between validation and expressing business rules. And one of the and maybe this is like just about the only downside I can sort of identify. When I was writing, as you saw there in the register customer use case, because that is written first, and it doesn't depend on the controller action already doing some validation as the data kind of comes in. One kind of needs to write validation in there because we need to be sure that, hey, actually, we've got to be sure that we got the, did we get a customer registration even kind of coming in, or maybe that's null. Potentially, I think inside a ASP.NET Web API controller action, it would make sure, if there was a parameter, it would make sure that wouldn't be null. So in a way, that's kind of redundant. But because we're not writing the use case with regards to ASP.NET Web API necessarily, but maybe it could be in a Lambda or a Windows service where we not guaranteed that the the argument kind of coming in is null. We need to undertake the validation in there as well. So I had to kind of say, hey, is it null? What about the data fields? Do we have those? Yep. And then of course validation or a business rule, which is only there the expression of, hey, do we exist? Does the customer exist by email address in our repository? Yes or no? And of course, in the controller action, I repeat some of the same validation because I would like to kind of catch it there if I can. And with regards to the error handling, I know a lot of people are sort of into returning a result. Sometimes I will use that, but I feel a bit differently. I feel that oftentimes it's better to kind of throw an exception when there is a problem. And when I say a problem, it just means, okay, here within the scope of this method, I can no longer continue my work. Okay, like for example, when we the customer was duplicate, so they'd already registered before. We found them by the email address in the repository. I throw an exception because it's like, hold on, I can't carry on from here. I'm going to tell my caller, my manager, or whoever's interested in it, that there was a problem. Usually when it's fatal, like that one, okay, hey, the customer already exists, I can be all transitive about it. I can, I don't want to pass a result back through all the transitive layers, check whether there was a problem with the result and kind of pass it back to the caller. I would like to kind of throw an exception, and that exception can just kind of travel up to wherever it needs to go. And whoever is concerned with those exceptions, and oftentimes it would be at the application boundary. So for example, here would be in the controller action. Catch the exception. The exception would be of a particular type. Maybe here would be an abstract type like data input exception. Okay, cool. And that would be, funnily enough, in a web API, that would be converted into a 400 bad request, which is basically what you would have here. 400 bad request, customer already exists in the system or something like that. That's how I like to handle errors. I hope that makes sense.
It does indeed. Thank you, Olaf, so much. We have so many more questions. Maybe you could reply to them later on YouTube comments. Thank you so much for being with us, being with Tech Excellence. Hopefully it wasn't the last time we are having you here. It was such an amazing session.
Oh, good. Look, I hope you have me again. If it was useful, if people liked it, if not, then that's cool too.
Yeah, I also want to
here.
Yeah. Thanks. Yes, sorry about that, but yeah, I want to say today we had so many questions and so much conversation within the audience. So yeah, after this ends and then tomorrow when the video is published, you'll see it all in live chat. So then, since there's so many other questions we couldn't cover, feel free to add YouTube comments. It was really great to have this discussion, and I also really personally enjoyed watching the way that you really made it simplify the explanation of clean architecture. So I really enjoyed it. Thanks a lot.
Fantastic. Thank you.
Thank you. And now the slide you have been seeing for a while. Our very next Tech Excellence session is our Tech Excellence Conference 2024. Register and learn from industry best speakers and deepen your expertise across Tech Excellence topics. You can register via this QR code or on Meetup app. Also, thanks again to our sponsors, Opsivan, Mocha IT, and Codartify. And if you want to deepen your knowledge in TDD, legacy code, DDD, and hexagonal and clean architecture, you also can follow the links to the e-learning courses. And join us on Meetup, and you will be notified immediately about our further events. And have a great evening, and you all enjoy your day. Thank you so much.
Thank you.
Thanks.